Okay, we're in the expressions unit, so let's actually get into expressions with this one. It was a good thing to start off with exponents, and hopefully those weren't too hard for you. In fact, they should have probably been a good lead-in to what's going to come up next. Now, order of operations is the title of this lesson, and it's a very important lesson, okay? You may have seen, if you're on social media, or maybe your parents are on social media, you can ask them if they've seen anything about the order of operations come up on their feed. It's so important and apparently so confusing that it actually goes viral sometimes. People actually share math problems about expressions and order of operations that travel everywhere to see who can get it. Okay, I'm gonna leave this right here, and I'm serious here. Order matters, okay? We saw that in the ratios unit, where whichever one I say first comes first in the ratio or in the numerator. With expressions, order definitely matters. And it doesn't matter what kind of expression we're talking about, okay? I'm gonna introduce you first to two kinds of expressions, two basic divisions of expressions. One is called the numeric expression, and this is the one we're going to spend a little bit more time with today. And then there's also this thing called the algebraic expression, okay? Big difference between these two is that a numeric expression is a numbers only club, okay? There are only going to be numbers and operations in a numeric expression. But in an algebraic expression, we're actually going to see some variables. Okay? We'll get to algebraic expressions in the next lesson, but for now, let's really focus on what a numeric expression is and what are the steps to finding out what the value is of a numeric expression, okay? I don't like using the word solve with an expression because that's not really what we do. What we do with expressions is we evaluate them. We want to know what the value of an expression is. Let me give you a quick rundown of the rules. Okay, you've probably seen this little acronym before. Back in my day, it was called Please Excuse My Dear Aunt Sally, and that's the mnemonic that we used to try to remember it. Have you heard that word, mnemonic? That's an interesting word. And I'm probably pronouncing a little bit, I said mnemonic. It's not mnemonic, it's mnemonic, okay? And it's spelled so weird. Okay, so the mnemonic is just like a little tool that you use to try to remember something. So the tool, the mnemonic that we used to use was Please Excuse My Dear Aunt Sally. And that right there, ladies and gentlemen, helped us remember what the order of operations was, okay? Nowadays, we don't really remember the whole sentence, please excuse my dear Aunt Sally, because really, it's kind of distracting. Who's Sally? Who's named Sally anymore? I know a few Sallys, actually. What did she do? Why do we have to excuse her? I don't know. But basically, now we just stick to an acronym, which is a word made out of the initials of the thing you remember. And most people will just say, hey, look guys, it's PEMDAS. And there are other variations. I've heard people use BODMAS, B-O-D-M-A-S. It's hard to pronounce, so I don't use that one. It means the same thing. And I've also seen GEMDAS, because parentheses and grouping are kind of the same thing. But I'm going to stick to PEMDAS for now, okay? And we'll make tweaks as we need to go. What does this stand for? Well, from left to right, this is the order that you're going to do operations in order to evaluate an expression, okay? P, I kind of already mentioned it already. I'll list them downwards like this. Oops. Parentheses. Okay? That's these guys. Now, one of the reasons they use GEMDAS sometimes instead of PEMDAS is because G stands for grouping. The P for parentheses can mean these parentheses. It can mean brackets, braces. It can mean any grouping symbol. And when you get into higher math, I think, maybe next year for 7th grade math, you'll also notice that a fraction bar counts as a grouping symbol. But we don't need to worry about that too much yet. For now, know that it's parentheses, brackets, or braces that all fit with that P because we're grouping things together. E, any guesses? Yesterday's lesson. Or the lesson before this one. Exponents. Okay, those are the things we did in the last lesson. Now so far, if we ever see an expression with both parentheses and expressions, we're going to do whatever's inside of the parentheses first. And when that's done, we'll say, do I have any exponents in here? And I'll do those next. Now after that is where it gets a little tricky. And this is where those viral Facebook and Twitter things get a little bit confusing. These two, MD, you can probably guess what those mean, right? This means to multiply and divide. But here's the thing. Let's say you have an expression with both multiplication and division in it. You're not going to do multiplication necessarily first before you get to division. You're actually going to do both of these at the same time. Left to right, okay? So if you have an expression that's kind of laid out over this way, and division happens to be the first thing there, you're going to do that first if you have both multiplication and division, okay? Do whatever is leftmost first, and then work your way left to right, okay? If multiplication is the first thing, do it first. The AS at the end, I bet you can guess what that is too. Add and subtract. And the rule is the same. We don't do addition first before we get to subtraction unless addition is first, reading left to right. Okay, so multiplication and division happen at the same time. Read it left to right. Addition and subtraction happen at the same time. Read it left to right, whichever one comes first. Here's this, just so you have it there handy for you to use, but nothing works better than examples, right? Pause this if you need to finish copying it or finish drawing arrows or whatever you need to do, and then join me back here and let's do some examples. Let's start with something relatively simple. Let's say I have an expression that says 9 plus 15, and then we divide 5, and then we multiply 13. This is a numeric expression, okay? I would like to evaluate it. In other words, bring this all together so I can see one value for this whole expression, okay? What am I gonna do first? I'm gonna make my little PEMDAS mnemonic over here, but I'm not gonna spell out what everything means. Sometimes it's just a good little tool to have off to the side to remind you what order to do these in. It's kind of like multiplication. Maybe it's something that you want to take from your brain and put it somewhere just so you can look at it, you know? So P stands for parentheses. Do I have any parentheses in this expression? Definitely not. I don't have any grouping symbols at all, okay? Any exponents? No, the only exponents for any of these is the exponent 1, which you can't see, it's just kind of implied, but that doesn't really count because the exponent 1 doesn't change anything. How about multiplication and division? Again, same time, left to right, okay? So, should I do multiplication first, since it's first in PEMDAS? No, because we're going left to right, and division comes first, right? So I'm going to do the division problem first. It's very important to stay organized when you're doing order of operations, when you're evaluating numeric expressions. Trust me on this, guys, okay? Anything you don't change, you're going to want to rewrite on the next line. Am I doing anything to that 9? I'm not. I'm not doing anything to this. So I'm going to rewrite it, okay? The only thing that I'm going to change is the operation that I'm doing first. So 15 divided by 5 is 3, okay? So I will write 3 here. So 9 plus 3. And I haven't changed multiplication either. I haven't done anything with this yet. So I rewrite this. Okay, see how this is line 1 and this is line 2? If it takes a whole page, it's okay, but please stay organized. Otherwise, everything gets really confusing really fast, and then you get the wrong answer and you feel bad. So, next step. I've done all of my, I've done division, but I still have multiplication here, okay? So that's next. So line 3 will have this brought down because I haven't done anything to 9 plus yet. 9 plus what? Well, I have to multiply 3 times 13 to figure that out, okay? I know that 3 times 3 is 9, and then 3 times 1 is 3, so that's 39. Okay, so there's my next row. Any more multiplication division? Nah. So now we move on to addition subtraction. I can see here that I only have addition, so there's only one more step, okay? 9 plus 39? 9 plus 9 is 18. Carry a 1 here, so that's 48. And the value of this numerical expression should be 48. Okay? Assuming I followed the right order, and I'm pretty sure I did. What if I didn't? Let's try something. Okay? I want to try to see what happens if I did MD, did multiplication first because I was fooled by the PEMDAS. I didn't change 15 divided by. So what's 5 times 13? I know 5 times 12 is 60, so add 5 more, that's 65. Do you see what's going to happen here? Because division, according to PEMDAS, if I didn't know the thing about the multiplication and division at the same time, is now 15 divided by 65. And that's going to give me a decimal, which is okay. But is it going to be the same answer as the one I got before? No, absolutely not. See how important that is? Let's step it up a little bit. Let's evaluate this one. Okay? This one has parentheses, and inside is 11 plus 42 minus 5. And I'm going to divide that by another set, 11 minus 4. Okay? There's a way to say this, and I want you to be familiar with this word quantity, because whenever you see a whole bunch of stuff inside of parentheses like that, you're basically going to read it as, what is the quantity, 11 plus 42 minus 5, divided by the quantity, 11 minus 4. If you only have one operation in there, then you can read it this way. The quantity 11 plus 42 minus 5 divided by the difference of 11 minus 4. If you only have addition inside the parentheses, you could read it as the sum of these numbers. And though, when you say the sum of, the difference of, the quantity of, that pretty much automatically means that you're saying, put this in parentheses. That'll be important when we start actually writing out expressions. But for now, our focus is on, can we follow the order of operations here? First thing, do we have parentheses or any grouping symbols? Absolutely, we have 2 spaces with those, okay? So, inside of these grouping symbols, I still have to start over. Let me see if I can rephrase that. Looking at these parentheses right here, I have to start over from here, okay? So inside of, let's just focus on these parentheses right here. Are there any parentheses inside those parentheses? No, there's not. Okay. Is there any, are there any exponents inside of these parentheses? No. Is there any multiplication and division happening in here? Nope. So far we've pretty much skipped all the way to the end because there is addition and subtraction in here. And again, inside of the parentheses, left to right, folks. Okay? So 11 plus 42? 53. Okay? Minus 5. And notice I'm going to rewrite this whole thing, except for what I changed. I didn't do anything with this yet. I'll get to that. I'll get to you in a second. Okay, so let's go ahead and finish this set. 53 minus 5, 48. And now that I only have one number here, you could go ahead and leave it in the parentheses, but you really don't have to. Okay, in fact, I make it kind of a habit that once I've done all the operations inside of a parentheses, that means I have cleared these parentheses. We don't need them anymore. Bring back down our division sign, and now let's do this group. What's 11 minus 4? 7, right? And again, that leaves me with one number, so I don't have to do anything with that. Okay? Let me check my math real quick. That's 48. 11 minus 4 is 7. Good. So I have one more operation left. If it's the only one left, then I'll just do it. I know 7 doesn't go into 48 nice and cleanly, so I'll do it like this. Good practice. 7 goes into 48. Not quite 7 times because that's 49, so we'll put 6. That leaves me with 6 right there. And I'm going to go ahead and write this as a fraction because why not? Numerator, denominator, 6 and 6/7 is the value of this original expression. Okay? You won't always get pretty clean answers. This is 6th grade math. This isn't 5th grade math. Okay? So here we put in the parentheses. Not too much of a change, not too difficult. Just make sure that that's the first thing you do is work everything inside those first before you do any other operations. Now let's introduce our friend, the exponents. See how we handle this one. Okay. This one, I won't make it too crazy. Let's do, I'm gonna get a quantity of 9 plus 33 minus 6 divided by 6 minus 3 to the 3rd power. Okay. Exponent this time. So I have a grouping symbol here. So I know that's coming first because that's what PEMDAS tells me to do first. Get what's inside is finished. Get rid of these parentheses. So 9 plus 33, again, left to right. 9 plus 33 is 42, right? And then I'm going to rewrite everything I haven't changed. Okay? Still got some parentheses here, so let's get rid of those. 42 minus 6, 36. Don't need the parentheses anymore. And then rewrite everything I haven't changed. How tempting is it for you right now, be honest, to divide these two? Should you? We just finished parentheses. What's the next step? Get the exponents done, okay? Now in this case, it's probably not gonna make a big difference. But if you just say, oh, I'm just gonna get division out of the way because it's right there, that could lead to problems down the road, okay? So don't worry about division right now. I'm not gonna change division, so I'm gonna rewrite all of that, okay? Now here I have minus 3 to the 3rd, okay? I don't have negative 3 to the 3rd. This is a minus sign, so I'm just looking at this piece, okay? Notice I brought down the minus sign. So 3 to the 3rd power is 3 times 3 is 9. 9 times 3 is 27. Okay, we're done with the E part now. Move on to the MD. Any multiplication? No, but it doesn't matter anyway because at the very left is division, so we'll do that first. 36 divided by 6 is 6. And then rewrite what I haven't changed over here. And then I only have one operation left, and that's subtraction. This is 6 minus 27, which, remember, we don't mess around with subtraction if we know we're dealing with integers. It's gonna be much easier for me to change this to 6 plus the opposite of 27. The signs are different, right? What does that mean? If the signs are different, that means I'm going to take the absolute value of these two numbers and subtract. So the absolute value of negative 27 is 27, right? Minus the absolute value of 6, which is 6. 27 minus 6 is 21. And keep the sign of the larger absolute value. So 21 is my number. My biggest absolute value is 27, so I'm going to keep the negative. The cool thing about video courses like this is if you watch this last part right here, where we dealt with the integer, the subtraction of the integer, and you're like, wait a minute, whoa, what did he do? What is this? You can go back to our integer unit and review addition and subtraction of integers, okay? If this kind of blew your mind, you don't quite know how I did this, or if you kind of felt uncomfortable with it, go back and review, okay? So here's what we brought in the exponent, had some grouping symbols, okay? Sometimes this might be a little confusing, but the nice thing is you always have a roadmap, okay? You always have this mnemonic to remember, how do I handle these? Let me find one more interesting one. Ooh, here's a fun one. One more, and then I'll let you get to the exercises. Now the exercises have some problem solving in there as well. So you're actually gonna have to read a story that involves setting up a numeric expression. And I really want you, based on what we learned here today, I want you to try to set those up on your own first. There are some keywords on a PDF underneath the exercise just to see if they help you. Helps you with what words do I use for addition, subtraction, stuff like that. I want you to try those first, and then when we come back together to do the exercise review, I'll spend a little more time on those word problems to make sure that you're okay with how do I read and turn English into math, okay? But for now, let's do one more skill. This one says 6 plus 3. The quantity 6 plus 3 squared plus 9 minus 10 divided by 5. Whoops, forgot my 5. Okay? So this one's kind of got a little bit of everything. I don't really see too much multiplication in there, but let's see how we attack this. This one's interesting. It's got parentheses with an exponent on the outside. So basically that means whatever happens in here, I'm going to end up squaring. So let's see how that works. First thing I know I need to do is do the grouping symbols, work what's inside here. I'm going to go ahead and start here on the left. I know that 6 plus 3 is 9, right? And again, I don't need the parentheses, but I do need to make sure I bring this exponent down, okay? Now, here's the thing. If this came out to be a negative number, then I would definitely want parentheses, okay? Because if the answer here is negative, that negative number stays inside those parentheses so that I square the whole thing. But since it's positive, either way. Plus, and then inside this quantity, 9 minus 10. Multiplication, division first. So, division here. I'm not going to do anything to 9 minus yet, so I'll rewrite that. 10 divided by 5? That's easy. 2. Okay? Now I'm not gonna work this out yet. I'm not gonna work this exponent yet because I wanna go ahead and make sure I follow the order of operations just to make sure nothing bad happens. So one more step inside this grouping symbol. 9 minus 2 is 7. Again, I really don't need those because it's just a single digit. Now I can move to exponents. And I have one here. 9 to the second power. Is that 18? No. Repeated multiplication. Exponent tells me how many times to represent the base, right? So 9 times 9 gives me 81, okay? Plus 7. And now there's only one operation left. 81 plus 7. 88 is the value of this expression, okay? This is your introduction to numeric expressions. Not algebraic, we'll get to that first. Numeric expressions and the order in which we must evaluate them. Order matters. Make sure you have your mnemonic standing by if you need it, and take it step by step. Don't try to do 3 different steps at once because it gets muddied together, and if you make a mistake, it's very difficult to find it, okay? So take your time. Keep it systematic. Keep it step by step. Keep it clean. Good luck on the exercises. I can't wait to see how you did, and I'll meet you in the video.